Hey guys, and welcome back to yet another video. Today we are gonna be doing a challenge from Advent of Cyber from TryHackMe, and we're gonna be doing day 4, I'm all atomic inside challenge. So this is blue team challenge, and we have to first of all start our attacker machine, so I just suggest you to do that if you're following along. Now let's actually read the storyline. So SOC Mass or SOCMAS is approaching, and the town of Verville started preparations for the grand event. Glitch, a quiet, talented security SOCMAS engineer, had a hunch that this year's celebration would be different. With looming threats, he decided to revamp the town's security defenses. Glitch began to fortify the town's security defenses quietly and meticulously. He started by implementing a protective firewall, patching vulnerabilities, and accessing endpoints to patch for security vulnerabilities. As he worked tirelessly, he left breadcrumbs, small traces of his activity. Unaware of Glitch's good intentions, the SOC team spotted anomalies. Log showing admin access, escalation of privileges, patch system behaving differently, and security tools triggering alerts. The SOC team misinterpreted the system modifications as a sign of an insider threat or rogue attacker and decided to launch an investigation using the Atomic Red Team framework. And we are gonna be using in this challenge that Atomic Red Team framework. So before starting, I want to say a couple of things. So I haven't actually done this box yet. As you can see down here, I haven't completed any of the challenges, and I just read the theory, so I will not have to read it aloud on the video, and I can just talk about it pretty simply. So we start by, so the page starts talking about detection gaps, and it talks that every blue team engagement has some gaps. So for example, and the example it gives is that, for example, the CEO is traveling with business and he logs in to, for example, an admin panel from Europe instead of the US. And our blue team detection systems get triggered, and we see that there might be an intrusion, and it is not an intrusion because it's our CEO. So this means that our security has some gaps and we have to review everything manually. And we can see that every attack is initiated via this cyber attacks and via this kill chain. So first we start by initial recon, initial compromise, then we establish a foothold, then escalate privileges, and we see this like a wheel. We get internal recon, move laterally, maintain persistence, and this goes on until we complete our mission, and the mission is complete. So this is the mission of a red teamer. And as a blue teamer, we have to prevent everything since the initial recon. We have to block the initial recon. So we have to block every single thing in the cyber kill chain. And yeah. So moving on, we have MITRE ATT&CK framework, and this is just a framework that lists all the TTPs, and TTP is a tactic, techniques, and procedures. So basically, this is ways that attackers can attack systems in a organization or attacking an individual. But MITRE ATT&CK kill chain is mostly for organizations or enterprise attacks. And we see that we get introduced with Atomic Red, and Atomic Red is a library, is a collection of red team test cases that are mapped to the MITRE ATT&CK framework. So we can quickly search MITRE ATT&CK framework, basically TTPs. And then we see that we get some more storylines. So Mixed Kitty has a vague idea of what happened to the compromised machine. And the compromised machine is in quotes because it wasn't really compromised. I think so. And it seems someone tried to use the Atomic Red team to emulate an attack on one of our systems without permissions. The perpetrator also did not clean up the test artifact. Let's have a look at what happened. And Mixed Kitty suspects that an attack called spear phishing might have been used from the MITRE ATT&CK framework, and its ID is T1566.001. So we are gonna search for this TTP and examine everything that happened. And we can start running Atomic framework by listing all of the commands for it. So using get-help, invoke atomic test. So let's actually do that. I have connected to my attacker machine via X3RDP, because if I connect through browser, my cursor gets screwed up and it looks ugly. So if I go to the command prompt and I zoom in a little bit, I hope I can zoom in. No, not really. Alright, so I hope you will see everything fine. Let's hope so. And now let's type get-help invoke atomic test. Right? Let's see. And we have all of the system syntax for invoke atomic test. Great. So now let's see what else is explained here. And we can see that we have all of, not all of the commands, but some of the commands, some of the most popular commands that you're going to be using throughout your journey. And this is how we can test for that spear phishing attack, T1566.001. Right? So now let's run our first command, which is going to list all of the details for that attack, which was T1566.001. So let's invoke -atomic test T1566.001, right? And then -show details. So -show details. So let's list all of the details of the command. And we have a bunch of data here. So the technique is phishing, and we have some information about the attack description. This atomic test downloads a macro enable document from the Atomic Red Team GitHub repository simulator, and user clicking a phishing link to download the file. The file phishing attachment.xlsm and phishing attachment.exe are downloaded to the temp directory. Right, so we can see attack commands, and these are all of the commands that were run throughout the attack, and we see the technique, and we see even more information about the attack. I think this is just another attack or another command that has been run against our system, and we can see the dependencies here and the cleanup commands. All right, so we have listed all of the information here, and we can see the broad summary of all of the output over here. So let's now continue and run the first test of T1566.001. And as I told you, I haven't done anything just yet, so this is my first time doing everything, and you can follow along as well with me. So yeah, so now let's invoke atomic test on the same operation or the same tactic. So let me just get the same command, and now we are gonna to test numbers and check prereq probably. Let's see, what does -check prereq do? It's probably listed up here, so let's see. Check prereqs checks provides a check if all necessary components are presented for testing. All right, so let's initiate this test. So dash test numbers, and then 2, and then dash check prereq like that. Okay, now let's initiate this test. Okay, and we have some sort of an error. A command shell and use an IP address in the command line. I know it's pretty hard to read, I'm sorry. I don't have actually any idea how to make it bigger. I don't think it's possible. All right, so let's move on now. And in this check, we have check prereqs for T1566.001 to word spawn a command shell and use an IP address in the command line. Prerequisites not met, and word spawn a command shell and use an IP in the command line. And Microsoft Word must be installed. Try installing prereq with the dash get prereq. Do we have actually all right, so based on the output, we can determine that the test was successfully executed. We can now analyze the logs in the window event viewer to find indicators of attack and compromise. Let's see, did I actually do everything right? I think I don't need to check prereqs, and I just need to check prereq like stated in this command. So let's see. We still get the same error actually. So I'm not actually sure what is the problem. Let me try running this command using dash get prereqs like that. We still have that prerequisite was not met. Let's hope this will not make an issue for us, because this machine doesn't have access to the internet, and we cannot actually install our additional tools that we may need. So let's see. Now that we have verified the dependencies, let us continue with the emulation. Execute the following command to start the emulation. Invoke atomic test with test numbers 1. Let's try doing just that. Let's run this command. Done executing test. Okay, based on the output, we can determine that the test was successfully executed. We can now analyze the logs in the window event viewer to find indicators of attack and compromise. Okay, so now that we have executed the atomic, we can look for log entries that point us to the emulated attack. For this purpose, we will use Windows event log. This machine comes with sysmon installed, so let us run sysmon. And do we actually need to do that? I don't think we are required to do that. Maybe later we will have to do something for the tasks. I haven't looked at the tasks either. I'm just running through all of these instructions for now. And after we get through these, we will do all of the tasks that are necessary for the exercise. All right, so make it easier for us to pick up the events created for the emulation. We will start by cleaning up files from the previously test by running invoke like this with cleanup tags. So let me copy this command and paste it to my terminal or PowerShell, and we have cleaned up successfully. Now we will clear the sysmon log event log. So open up event viewer by clicking the icon in the taskbar or searching it or on start menu. Navigate to applications and services, Microsoft Windows sysmon like that. Right click operational. All right, and we will clear the log. So let us go to event viewer. Oh my god, this machine is pretty slow. I think that's the one. We can just click on this one. Let's see. Yep, event viewer. Then applications and services like this. Or do I have to click on it? Microsoft. I have to find Microsoft. I think it's lagging a bit. Yeah, okay. Microsoft, then Windows. Then we have to find sysmon, so I'm just gonna press S to search for anything that starts with an S. And then let's see sysmon here. And then operational, we have this one. And then right click operational and clear log. So right click and then clear log like this. And I don't think I need to save it, just clear. All right, we have cleared operational. So let's see. Now let's invoke atomic test again. Let us run the emulation again by issuing the command invoke atomic test with the tactic number and then test numbers 1. And then click on enter. Yep. All right, we have done executing the command. Next, let's go to event viewer, right click on the operational log, and then click on refresh. Let's see. Right click here and then click on refresh. We have some information, that's good. There should be new events related to the emulated attack. Now sort the table on the date and time column to order events chronologically. The first 2 events of the list are tests that Atomic executes for every emulation. We are interested in 2 events that detail the attack. First, a process was created for PowerShell to execute the following command, and we have the command here. Then a file was created with the name phishing-attachment.xlsm. Click on each event to see the details. When you select an event, you should see a detailed overview of all the data collected for the event. Click on the Details tab to show all of the event data in a readable format. Let us take a look at the details of these events below. The data highlighted is valuable for incident response and created all alerting rules. Right? Okay, so what we have to do is click on Details and sort by date and time. Let's see. That looks incorrect because we have to check from the earliest to latest. I think that's correct, probably. So these are created by Atomic, probably, as was stated in the tutorial. Click on the Details tab to show all of the. Which one do I have to select? That's my question. Let's see. 42, 41. The first 2 events of the list does that we are interested in 2 events that detail the attack. Okay, so these first 2 are not interesting for us, I think. Now let's see the next one. Yep, the next one is PowerShell.exe, and the command line is PowerShell.exe with the following URL. We have URL 2, and we are outputting to our environment phishing-attachment.xlsm. Okay, we have the data for the we have the logs. So now let's see, navigate to the directory temp and open file phishing-attachment.txt. Let's go to that directory. So this PC, C disk. Let's wait for it to load. Users, administrator, app data, local, and then temp, and now there should be phishing-attachment.txt. Let's open it and see what we will get. Let me close everything here. Should be opening, I think. Oh, it's over here. And we have the first flag that we will need for the challenges. So let's see. What was the flag found in the .txt file that is found in the same directory as phishing attachment.xslm artifact? So let me paste this flag and it is correct. So we now found where our attacker say ran the executable and where was all of the files from the attacker found. Let's see what we are asked to do next. So let's clean up the artifact from our spear phishing emulation by running this cleanup command again. So let's do just that. Now that we know which artifacts were created during the spear phishing emulation, we can use them to create custom alerting rules. In the next section, we will explore the topic further. Alright, so alerting on the atomic. So now, in the previous paragraph, we found multiple indicators of compromise through the sysmon event log. We can use the information to create detection rules to include in our EDRs, SEIEM, and IDS, etc. These tools offer functionalities that allow us to import custom detection rules. There are several detection rule formats, including YAR, Sigma, Snort, and more. So I believe we are going to be creating Sigma rule for this, I think. And so based on these arguments that we saw being ran on the in the events, we can create this Sigma rule, which checks for these things. Detection parts where affecting detection is happening. We can clearly see the artifacts that were discovered during the emulation test. We can then import this rule into the main tools we use for alerts. So we can create this rule, and after creating this rule, we can import this rule to tools like Chainsaw on Linux. I know that's the only tool that I've been using earlier. I'm not really into blue teaming, so I don't know a lot about all of these rules and everything. But we can import the rule to, for example, Sigma, to Chainsaw, and it will extract all of the events that occurred in our logs based on this rule. So that's pretty cool. Okay, and now we have the challenge. So as Glitch continues to prepare for SOCMAS and fortifies Vervile's security, he decides to conduct an attack simulation that would mimic a ransomware attack across the environment. He is unsure of the correct detection metrics to implement for this task and asks you for help. Your task is to identify the correct atomic test to run that will take the advantage of a command and script interpreter, conduct the test, and extract valuable artifacts that would be used to create a detection rule. So the task is to extract valuable artifacts that would be used to create a detection rule, right? Okay, so now let's go through all of these questions. So what attack technique ID would be our point of interest? So let's go back up to where we have, so we have this spear phishing. I believe this will not be the answer. Let's see. ID. So maybe if we delete this 001, nope, that's not that. So let's go to MITRE attack, MITRE attack framework. Let me actually clear these tabs. Okay. MITRE attack. That's the framework that was mentioned in the task. Let me search for that technique that we were after earlier. Let's see. Will it find anything? Technique ID. So do we have to actually find it through? Is this the technique ID? I'm not actually sure. Okay. Phishing, spear phishing. Yep, that's the ID. So yeah, that is the ID. So we are not after this one in particular. All right, let's go back to the RDP. And we have cleaned up. So I am not actually sure what we are after here. So based on the Sigma rule, we might be interested in maybe this ID. Let's see. I hope that's the answer. Yep, that is the answer. And I guess that because we can see that PowerShell is here. And if we would go to MITRE ATT&CK and search for this ID, we would probably, yep, we find PowerShell subtechnique T1059.001. All right, great. What attacks subtechnique ID focuses on the Windows command shell? Let's go back to the RDP and I will initiate all of the tests for the technique that we are interested in, which is T1059.001. I will click enter and wait for it to execute the test. I am not sure if I am supposed to do that. Technique ID focuses on the Windows command shell. Command shell, so maybe I have to paste the whole ID now. Let's see, spear phishing attachment, web service application layer protocol. I will take a hint for this one because I actually have no idea what I am supposed to do here. So let's see. External research. Look up the MITRE ATT&CK subtechnique ID for command and script interpreter. All right, so I'm gonna do that. I will copy this and paste it to, so this is mobile, this is not interesting for us. PowerShell subtechnique T1059.001, I believe that's, yep, so that's probably not interesting for us. 001. We have just looked at this technique. Unix shell. Windows command shell. So that should be this one because PowerShell and yeah. Let me try it again. Maybe I copied it wrong. Nope. Let's see. There are a lot of procedure examples, but I'm not sure we are interested in those. Subtechnique of T1059. Let's find all of the subtechniques. Windows command shell. Maybe this is the one that we are interested in. Let's see. Windows command shell for execution. So that's probably the answer. Let me paste this and yep, that is correct. All right, let's move on. What is the name of atomic test to be simulated? Atomic test to be simulated. So my guess is that we have to reference to this subtechnique, command and script interpreter, Windows command shell. This is a very long answer. So, I don't actually think we are supposed to, or maybe we are supposed to invoke the test on the Sub-technique above. Atomic test to be simulated. Let me type in the command that we have entered previously to get the information. I think that's the show details one. Yeah. So invoke atomic test T1059.003. Yep, this one ran wrongly because it had to install Mimikatz from the internet, and we do not have access to the internet. So let's I forgot the information flag. Oh damn. All right. Let me try to do this once again. The show information, is that correct? I forgot already. Show details. Show details. All right, it's giving us a lot of information. Let's read it from the top. Where did we start? We started here. Okay, so technique is command and script interpretation, Windows command shell. Create and execute batch script. Atomic test name. It's probably going to be the answer for the question. Let me see. Or maybe not, because it's way longer. Atomic test to be simulated. This looks way too long for the answer. Yeah. And is only 3 letters, and it asks for more, so that's not going to be the answer. Let me scroll down to get more information. Or maybe I just have to run without the sub technique, maybe the volt technique. Nope. Let me take a hint for this question as well, because replace the sub technique placeholder in the command invoke atomic test sub technique dash show details with the one found in question 3. And the question 3 was this one. Look for atomic test names in regards to malware. So I think we were on the right path. We just didn't read enough information. So let me scroll up a bit. Okay, so this one is not interesting for us. Writes text to a file and displays it. Probably not interesting. Suspicious execution via Windows command shell. That is probably not correct either. And simulate black byte ransomware, print bombing. This looks more interesting. Let's see, PowerShell, CMD. It has this ransomware.txt. What is the name atomic test to be simulated? It's probably this one. I would assume so. Let's see. I didn't copy it. Let me copy it again. I hope I can copy from the simulate. Yep, I can. Okay. And this is the correct. So the name of the atomic test that we want to simulate is black byte ransomware print bombing. What is the name of the file used in the test? So the file name we have found earlier was where-while ransomware.txt. Yep. And what is the flag found from this atomic test? So I don't think I'm gonna do the volt test to initiate the volt test. Let me just try to find it in the folder. So let's go back to the C disk. Tools, atomic red, team, then atomic. This operation name, which is from the, I believe it was the command and scripting interpreter PowerShell, yeah. Let's see, we have to find, let me just copy the name and this one, all right, and then search, open this folder, then the source, and then we see the Vervile ransomware. And yeah, we have the last flag, which is this flag right here. Let's read what it says. Glitch is working on testing the security posture before SOCMAS is here. I will run as many tests to ensure we are all safe, and we have this flag. And also we have something base 64 encoded, so I'm gonna check it once I submit it. Let me see. What is the flag found for the atomic test? So this is the flag. All right, so now let me copy this base 64 encoded thing and let me try to figure out what it is. So let's go to the CyberChef, and CyberChef is a way to encode and decode data. Let me paste in this input and we can decode from base 64. And it says glitch is not the enemy. Yep. So we have figured out all of the tasks for this challenge and we have solved everything. So yeah, this was pretty fun challenge. I didn't know anything about all of this data parsing. It was new to me. I'm sorry if I was pretty slow doing everything, but I'm learning as well as you are. I hope you learned something new from this video. And yeah, let me complete the last challenge. And that's it. So I will see you guys on day 5. And thanks for watching and goodbye.